if I can buy it? Wasn't real with you, boy. Real, wasn't real with you, boy. You won't give me too much chances. I don't care if I am fancy brighter. Yeah, oh boy, I'm telling goodbye, yeah, oh boy, I'm telling goodbye. Chances I don't care if I am fancy brighter. Yeah, oh boy, I'm telling goodbye, yeah, oh boy, I'm telling goodbye.
Hello everybody, happy Thursday. Hopefully you're here for Python. If you're here for C++ or Java, you got the wrong time, I'm sorry. But you can hang out and learn Python too, it's fun. Sorry, I'm getting some weird glare from the window. I wonder if I can adjust this a little, which direction's better. Maybe if I just scooch over more? I don't know, sorry. Hopefully the lighting's not too bad. How you guys doing today? We are still in week 1 here. Reminder, no lab on Labor Day. Go enjoy the holiday. We're not showing up doing anything there. And for labs, I'm not planning on actually streaming anything. Like, there'll be a lab assignment posted in Canvas, and typically you guys just work on it and I answer questions about it. There's no lecture going on. It's your chance to be in front of a computer and try some code. So this format actually hopefully works out better because you can be writing code like while I talk too, or be trying things if that's how you like to learn, rather than sitting in a classroom with no computer and watching me do stuff, which I find confusing as to how you learn how to do stuff just watching, but that's okay. So I'm happy for this format, and hopefully you guys can follow along. So we've got our introduction. We used Pycharm briefly. No, we didn't even start with Pycharm on Tuesday. I'm forgetting. The days are all running together in quarantine here. So we'll show you more about GitHub, more about Python, and using Pycharm. It's my preferred IDE for teaching this, at least as an object-oriented language. I should put my phone on silent. There we go. Cool. Yeah, you guys should silence your phones too, you know, make sure it doesn't bother anybody. That's what we got today. So no lab. Next week we'll get into chapter 2 of the book. It looks like so far 7 of you have registered for the book. Again, you do get 10% of your grade just for doing the book. And I shouldn't say just doing the book. It's actually more involved. It's a really cool tool. It has these really interesting interactive, you code right on their webpage for the book, and it will tell you whether or not you did it right, which is fantastic. It's, I don't think, as interesting as us doing a lab in person where I can walk around and help you and do that sort of stuff, but it's really good practice. So I do recommend you don't get behind on those, because those, they call them Xylabs. take a lot of time. It's very particular about your spacing and your new lines and all that stuff, and we can talk about some tips for getting those in correctly. But again, I strongly believe the only way to get good at coding is by coding. So you'll do some coding for Zybooks, you'll do coding for me in the labs, you'll do coding for me for the projects, and you'll be coding for your final project. So tons of your score, right, 25% here, 25% here, I mean, this is not all coding, but it's some practice, and then 10% here is coming from doing that. And then, as a reminder, I will have a quiz for every chapter we talk about, another incentive for you to go and read the material. Again, don't go to the point of like trying to memorize every single word anywhere. The quizzes are open book, open notes. They're essentially time limitless, but except for the due date. So you can start it at any time you want, come back to it. You should be able to save your answers. I'm pretty sure Canvas works well with that. If you run into trouble, let me know. But it's been pretty smooth for people lately. And go and answer the questions in the quiz. So you're not going to need to memorize anything out of the textbook. You definitely are going to need to do more than like look at the section titles. Right? There's that level of reading between you've read and tried to memorize every single stinking word, and you've just skimmed and just glanced at the section headers. You know, do at least the skimming enough, and if you do the exercises in Zybooks, you get points for that, and it's going to help you learn where the material is. Again, there's no development job in the world where they say you can't use these resources. You have to do everything off the top of your head, because we know that's stupid, right? You just can't have all the information in your head on how to use a language to solve problems. And that's okay, right? We recognize that, and doing our best to assess that as well here. And we do have a midterm, and we do actually have 15 people enrolled now. So I think we're not going to actually do it in person in the lab, but what I'd like to do is use that time that we would have been in the lab. So everyone will have the same window of time, but we just won't have to come in person and I'll watch you. In order to do that, it's going to be more work on my part because I have to create a large test bank so you all get different random questions, and not that you guys would cheat and get on a group chat or anything like that and answer all the questions together. But I've heard stories of stuff like that happening. So we just will discourage that by giving you random questions and mixing things up. And sure, again, don't engage in academic dishonesty or violate the academic integrity policy. I forget what we call it here. Yeah, violations of academic integrity. Don't do that. Just, stand on your own work and get it done. That's what we're doing here. Cheaters should fail and fail hard because they shouldn't get degrees and look stupid in the industry and make the rest of us with that same degree look bad. So again, so it'll be during lab time, but not in lab. So I'll update that, and I'll make sure you guys all know how that's going to work for you. And we should be good to go. So again, we'll do about a chapter a week. So after today, I'll open up the quiz. So I do write them myself. I don't use a quiz bank if I can help it, because I find those kind of questions terrible. So if you're not sure what the question is asking, please come ask me, email me, text me, chat me in Discord, right? If you're not sure what it means, someone else is probably not sure what it means either, so Discord's great for that. Everyone else can also see what my terrible question was supposed to be about, or if I had a typo, right? I'll be honest, it happens. So just let me know. And then I usually expect you to have it done within a week or so. So I'll lecture on the material Tuesday, Thursday. I'll open up the quiz, and it'll probably be due, say, by a week from Thursday. So you have the whole week to do it. Again, you probably don't want to get too far behind, and like once we start reading stuff in chapter 2, if you haven't done the stuff in chapter 1, it's not going to make as much sense. So, but you've got a couple extra days if you need it to pick up on that quiz. So that should work okay for you. I'm having some issues with YouTube for some reason. I tried to export the last stream, and for some reason YouTube hates it. So I'm trying. Again, you can watch these recordings on Twitch. The VODs are available for 45 days or so. Someone gave me some tips on how I can make them last longer, but hopefully by like mid-October, you're not going to need to come back to a lecture in chapter 2. But I'll do what I can. I'm going to try a couple other things. I got some suggestions from some folks in the Knowledge Fellowship. Again, shout out for TKF, exclam TKF in chat, and you'll get some links there if you guys want to learn some other interesting stuff Lots of cool people out there sharing some knowledge. So definitely thankful for their help with getting this up and running. All right, so I think we're ready to jump in. Oh, let me look. I did put the links in here, right? So I said Pycharm Ide. I forgot to link the Python download. So let me go add that before I forget. So python.org, and go to download. So you generally want to do this first. I'm sorry, I messed up those directions for you. If you ran into trouble, it should work if you do it after, but it's usually prettier if you do it first. Oh, look at that, even like had it right there. So I'll link the download page here for you. That'll probably be easier. Yeah, okay, and I need to go put that in the syllabus. Let's see, not in GitHub. All right. Oh, my computer's unhappy with me today. Here we go. We'll get this added. And then I can go update it here in Canvas. We should be all set. I've got last semester's GitHub or quick start guide that I put together to get you started using GitHub. It has everything that says fall 2019. I trust you guys are smart enough to figure out that it's not 2019 anymore, so I'm going to put that out there. What you're going to need to do is email me a link, or email me what your github.com username is. It's a free account. You can use any email address you want, any username you want. I'll be able to figure out who you are. Don't worry about it. Email it to me. Once you've done that, then I'm going to create your repository. You'll get an email inviting you to collaborate. You'll do these things, download the desktop client. Again, 2020, I'm sorry. I even have screenshots in here from 2018, so it's not that much work for me to do. I'm a little embarrassed I haven't done it, but it is stuff that really shouldn't matter too much, so I didn't bother to take the time. I apologize. That's me. And it walks you through how some of this stuff works. Again, I'll be showing you all of it, but if you like this sort of format, the guide's out there for you. Fantastic. And we need Python 3. Whatever. I'll just put 3.x, right? You know, the latest version should be fine. And did that mess up my paging? No, okay, everything's good. And I'd like to save these as PDFs. I don't know if that works any better for you in Canvas, but the PDF viewer seems to work better than the Word viewer for some reason. So I just export it as a PDF, and then I can give you the new version here. And we'll be off to the races. Okay. Fantastic. You know, I should have mentioned remote midterm, but I forgot. I'll do that later. Okay, so the new version's out there for you. If you have any trouble with that, let me know. Again, your Zybook link is in there, and the code that you're going to need to register for the Zybook. I guess it's totally up to you. If you don't want to do it, you don't have to, but you're just not going to get those points. And sure, that can be your call, whether or not you want those points are not there. So great. So I have the course repository here on my computer. I think we did this on Tuesday, right? I created the repository and I have cloned it to my computer. And you can do that right from GitHub. You click this big old green button here and you'll say open in GitHub desktop. If you've installed it, it will work in Link and should be fine. Yeah, other links, cool. Yours will be your username here, right? Your username here. Whenever you email it to me, again, don't do it right now because I'm in the middle of doing this, but I'll make you that repository and you can do your first getting started piece here. Usually it's the first lab, but scheduling is totally screwed up because of the holiday and we're not going to meet for lab. And it's not really a project to do it, so that will just kind of hang out there to be the first lab we do on, what day is that, the 14th, right, when we meet. And again, you don't have to come in person. You're welcome to do it remotely as well. Labs will be due the week after they're assigned by about 11:59 p.m. So generally, if you have questions and you couldn't get it finished, you've got the week to finish it and to see me in lab the next week to ask more questions. And do let me know. I'll take a poll of the people who actually do show up coming a week from Monday and see if you want to keep meeting in person or if it's just a waste of your time because I can't even stand next to you and look at your code. We'll have to do screen sharing from there. But you will have access to the college computers at least. So if you don't have a good development environment at home, that's an option for you to practice there in lab. Although, given that we don't really have open lab hours, that's going to be rough too. So if let me know if you run into problems with getting an environment to develop on. We've got some options. There's actually a couple really cool online environments that you can use for Python because it's an interpreted language. I think I mentioned on Tuesday, right? Python, the executable Python just reads the text file, whatever your py file is, and does the things that it says it to do, what we tell it to do. So it should work out relatively well if you need that sort of workaround, given the circumstances. But let me know. I'm happy to help you with what I can. I need some more coffee. I'm sorry, my cup's almost empty. I'm running low. There we go. And this thermal pot is amazing. I'm sorry I can't share with you in person. It keeps it nice and warm, or I bring my growler full of coffee. But next time, I hear we're currently in the planning stages of figuring out what we're going to do for the winter semester. So good news. If those of you in the data science program or master's program working on your programming prereqs, if you're planning on taking 2001 next semester, unfortunately or fortunately, you can make that decision. You're probably going to be stuck with me. I'm typically the one who teaches these two classes here in the data science program. It will be at the exact same time, the same lecture time, the same lab time as we do this semester. And again, we'll decide on the format later. The college administration is working on that as we speak. We have oodles of task forces or working groups or committees or all sorts of stuff that just sounds terrible, and I have no interest in participating. Thankfully, this is a technology class, a coding class. It's not all that hard to be remote. Hey, Uncle Bill, thanks for dropping by. Yeah, so we'll make do, and we'll manage with whatever the plan is when we find out more about winter semester. But again, we're not there yet. I'm sorry, I'm jumping way ahead. We still need to do stinking chapter 1 here, right? In Zybooks. So we got chapter 1. Right? Okay, so the Pycharm IDE. Again, if you like a different one, you're more than welcome to use it. Perfectly fine. It doesn't matter to me. I just like Pycharm. It's a nice little environment. And definitely you want something that has a debugger. That is one of the skills we're looking at assessing, that you can use a debugger. Right? Use your debugger to assist you in the process of identifying and removing defects from buggy algorithms. Woo! Okay, I gotta slow down. Have some more coffee. Oh, did I tell you, since I've got so many kids at home, we are homeschooling some of them. We got this crazy mix mash of learning stuff going on here. And we were teaching one of my little kids about rhyming. And you understand how rhyming works, right? The words have to sound similar and this or that. And my wife is a teacher by training, so she loves doing this sort of thing and has all sorts of fun with the kids doing it. I do some of the math stuff, occasionally some science stuff, and of course I invite them to the Twitch streams and be like, hey, you want to learn how to code? Watch Daddy code. So that's always fun. Sometimes they'll pop on, but they're still a little busy with their other stuff. But we were teaching them about rhyming, or my wife was, not we, and it turns out there's a couple words in the English language that don't rhyme with anything, except if you're Eminem. He found a way to rhyme some interesting words because the man's kind of a genius. But my little daughter, she comes up to me and she says, Daddy, guess what? Guess what? She says, nothing rhymes with orange. And I just look at her and I'm kind of confused, and I tell her, that's not true. Who taught you that? And of course, that didn't make my wife very happy with me, but all right, there's your free dad joke for the day before we get going. All right, so what we're going to do, now that I have my repository, remember your two most favorite links here are going to be View on GitHub and Show in Explorer. So Show in Explorer will show me where the local folder is here on my computer. And what I want to do is I'm going to copy this path. So if you just click on this little breadcrumb trail, it's going to copy it. And now I want to go to Pycharm and do a File, New Project. What I want to do is I want to start the project in that directory. Remember, Git is nothing other than a fancy file watching tool. It sits in a directory, has all the Git stuff behind the scenes, don't touch the .git folder, and will watch for files. So it says, hey, where do I want to put this project? I'm going to start it here in the GitHub repository, and then I'll call it, I don't know, September 3rd is going to be the name of my project. And then again, with the project interpreter, strongly suggest you use an existing one. I'm partial to the virtual environment. It's the right thing to do. Again, if you use the regular one, you're going to be perfectly fine. We're not going to screw anything up or break anything. And again, you're not running enterprise software, probably not running enterprise software on your machines there at home. So you should be fine, but a best practice, use the virtual environment for lots of reasons. And if you don't have one, you can make one the very first time. Other than that, don't hit new every time. This will just sit and spin for a while, and it wastes everybody's time. So just use an existing one. Virtual environment's fine. If you don't want to make one, that's okay too. You can use your base install. Should cause no problems at all. So we're going to make the project. I want to do it in this current window. I don't want to leave the other one open. And now I've got a project. The project here is just a folder. So if I right-click, come on. Oh man, right-click, and this one has a Show in Explorer option. I can see the folder that my Pycharm project is in now, right? Because a Pycharm project is a folder with some additional things. So here's the September 3rd folder. It makes a folder for the project. We love that. It keeps your code nice and organized and pretty. You want it nice and organized and pretty so we can all see it. No, the git ignore, sorry. The September 3rd folder, right, now has a .idea in it. The dot typically means it's a hidden folder in file systems. But again, you want your view settings to show you hidden items and file name extensions because it's just going to save you time. You just want that. Otherwise, you don't see all the stuff you might want to see. And you notice it's empty, but the idea folder tells Pycharm that it's a Pycharm project. And I can go and open this folder, open this project, because it'll see this here. And that's its convention, how that one works. So what we're going to do is we're going to add Python files. So right-click the project in Pycharm and say New Python file. A lot of people go right to new file. It'll work, but it won't know by default it's Python, so go to Python file. It'll just make life easier. And we'll call this September 3rd. Again, it doesn't need to match the name. Python could care less. You can name it Fuhugu Gods if you wanted, or however you pronounce that. It's been quite a while since I watched Homestar. That was his name, right? I feel like it was. I should remember better. Right, and it looks real boring here because there's nothing new. But if I come to my GitHub client, what I'm going to see now is a bunch of stuff. Right, I want the idea folder. It adds its own little git ignore stuff that it shouldn't have to deal with. There's a bunch of these other files, XML files, IML files. If they change, let them change. Right? Don't worry about them. Don't try and change anything. These are okay. It just is telling it, hey, here's a project. It uses this virtual environment, yada, yada. Here's the module that we're using. Here is some other stuff, your test runners. I never deal with any of these. Like Pycharm does it all for you, so don't worry about it. What you care about is this little py file, right? Great, there's one here. It's empty because there's nothing here now. And again, we'll do our print hello world because we have to do hello world. It is the rule. Anytime you write a program, anytime you're learning a new language, start with hello world. I'm going to right click and say run, and I get hello world results. Enhance, enhance, enhance. There we go. Is that better? So you can see hello world. Now in the GitHub desktop client, you should see this file now has one line. Fantastic. So we'll say hello world complete. Again, a commit is a snapshot point in time of this directory that we're calling a GitHub repository. Git will track these snapshots and track changes between snapshots. And that's how all the magic of it really happens, is it compares this snapshot to the other snapshot and looks for that line level detail of what changed where and when. And it's amazing. So we'll say commit. And I'm going to go ahead and push. Always push, right? Commit and push, commit and push, commit and push. You want to get into that habit. So just committing will mean your local repository, your local clone of the repository has the change. But github.com doesn't know about it yet. And if github.com doesn't know about it yet, I can't know about it yet. And if I can't know about it, you can't get a grade for it. I think that's proper English, right? So commit and push. Once we hit push, now when we come back to our GitHub repository, and if you don't have that URL saved because you don't, that's fine. Go to repository, view on GitHub, and it will open it up. Ta-da! Right, and now I see a folder. Right, GitHub is fantastic, and says, hey, this thing's a folder. I can click on it, and I can see the contents of that folder. You can see the idea. Don't mess with that one again. Here's the September 3rd.py. This is what we care about. This URL here, well, I mean, this one's mine, but with your username here and your stuff, forget that it says blob and master. Don't worry about that. It's not a big deal. But it's essentially, here's the repository folder. Here's the file path. Right. So if we take a look at this here, I've got my repository folder, CIS 1501 fall 2020. Right. There it is here. And I have a folder September 3rd. There it is here. Inside of that folder September 3rd, I've got a September 3rd.py file. If I can double click properly, there it is. So this link to the py file is what you're going to turn into Canvas. So all of your assignments in Canvas, all of your labs, all of your projects will ask for a URL, which is really cool that Canvas has that option. Some of the other course tools I use don't have a submit URL. It's just like submit text. And this one actually checks that it is an actual URL, which is pretty cool. This is your last check, right? If you can see it on github.com, I'll be able to see it again. I'll be able to see it on github.com. I have either had too much or not enough coffee, and my words are all running together. Oh yeah, that's good. All right, so hello world again. You'll turn in URLs. It's fantastic. If you have questions about your code and you're running into trouble, you can send me the URL, ping it to me on Discord, email it to me, whatever. You don't need to attach Python files to emails and send it to me. Right? Attaching code in email is like, it's a sin in the software world. Just don't do it. It's terrible, and people will make fun of you for it. We have collaboration tools for a reason, and believe it or not, the collaboration tools like GitHub are written by other software developers. Imagine that, right? So it's written for software developers by software developers. There's that great video of Steve Ballmer. It's hilarious. It's probably older than most of you, but that's okay. Ballmer developers. Let's see if we can find it here. This is worth your time, I promise. Yeah. Here we go. Definitely worth your time. I gotta unmute here. Let's see.
Developers, 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 developers. Developers, 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 developers. Yes!
Alright, I gotta be honest, maybe that wasn't actually worth your time, but kind of funny at least, right? I mean, give me that. Okay, so he was the... I don't remember if he was the CEO at this point or if he was the second guy in command. I forget if Bill Gates was up there or not still. But, right, written by developers for developers. Get excited, right? Get pumped. Let's write some tools that are going to help us solve problems. And that's one of the fun things. It's one of the things I like to focus on is tooling, right? So, I mean, solving problems is good too, but enabling development. Yeah, you know, unless you've been on stage in front of a lot of people, that sweatiness is it's amazing. It just happens. I think that's just comes with it. Maybe that's why Steve Jobs always wore the turtleneck, so the black turtleneck, you couldn't see him sweat. Maybe, I don't know. Oh, this thing is annoying. Yeah, can be added. Don't ask again, or we'll say, oh, I don't know. So Pycharm knows it's in Git, and you can go to like version control, and you can do certain things with it. I like that we can use the GitHub desktop client no matter what programming language we're using, whatever IDE we're using. You might prefer their built-in tools. So whatever, I'm going to go back and forth. I'll just not to ask me again, and we'll ignore it. All right, so we've gotten this far. We're doing pretty well here. We're going to get into specifics of programming. A little bit of a high-level piece of it here. Again, this class assumes no prior experience, so if you've done some programming before, I apologize. If you've not, and you find it interesting, fantastic. There's a lot more you can read in the textbook. I find this rather dry, and I'll go through it pretty quickly, but again, I maybe take a couple things for granted because I've been doing it for so long. So the idea behind a program is typically it takes some sort of input. right? Whether or not someone's typing, someone's clicking, someone's touching on a touch screen, or whether or not it's a phone, or coming over the network, or whatever it happens to be, most programs work on input. Right? If there's no input to the program, it's going to give you the exact same thing every time, because it's going to have to operate on things like that you gave it, that these things that we have coded into the program, like hello world. And that's just not very interesting. So most every program works with input. And then what we have is some sort of process, right? We tell it what to do, step by step by step by step by step. Here's the process. Here's what you do. X, Y, Z. And computers are actually really dumb. You have to give them every little detail. They don't know how to jump from one thing to another. So we need to break things down into smaller and smaller and smaller steps to the level of which a dumb computer can understand it and actually do the thing we ask it to do. So that's the processing piece here. So we can do arithmetic, right? The computer's decent at arithmetic, right? 2 plus 2, right? We should get out, what? 4, look at that. You guys are so good in chat there. Right? Enhance, enhance. So you can see it. Again, these little yellow ones are warnings that I'm not following the convention. I've gotten into the habit of putting spaces around parentheses because that's the format I've been using for years. They said don't do it. Sure, whatever. Again, it doesn't matter whether or not we have a space there or not. It will do the right thing here. And we could also say like times 7, right? And we're going to get 4 times 7, right? And we'll get, what is that, 28, right? When we run this thing. Uh-oh. That's not 28. Oh, wait. Oh, yeah. Math. There's an order of operations, isn't there? Because remember the order of operations? Everyone says something about one of their funny ants. I'm trying here. I know this part's boring. I'm sorry. Yeah. The PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Right? So the multiplication will happen first. We still have order of operations. Now, at one point, I had seen something like this go around online, and people on Facebook argue over stupid things. Remember, there's no winning an argument online. It's just not, you don't win. Right? People just talk at each other and argue, and it's a terrible, terrible thing. But just because you say multiplication before you say division does not mean it has a higher order of precedence. Right? Multiplication and division have the same order of precedence. So they're going to evaluate from left to right because they have the same order. So we get 2 divided by 2 times 7, not 2 times 7, 2 divided by this. Right? Does that make sense? So just because we say multiplication before division doesn't mean you do multiplication first. Okay? That has confused people before, and that really hurts my head because I feel like that should not be confusing, especially because I know all of you here in this class are at least enrolled in Calc 1 or beyond, right? So we've done, that's years and years and years of math classes you guys have suffered through. I mean, I shouldn't say suffer. I actually do find math very interesting. A fun fact about me, because you get to listen to my stories. That's one of the perks I get, I guess, right, of teaching, is that I have a captive audience for stories, is that when I got my degree, I didn't actually get a degree in computer science. I got a degree in information technology, or business information technology is the actual name of the major or something like that. I forget what you call it. And as part of that degree, the most math I needed was statistics. I actually had 2 stats classes, which was really cool. Stats is phenomenal math. I love stats, and it is the most practical math you can learn. I'm firmly convinced. You can do a lot of cool stuff with calculus, but I'm not convinced in day-to-day operations it's going to be as practical for you. But statistics, oh yes, especially those of you in data science. I'm guessing most of you are also interested in statistics, because that's like 1/3 of the degree, right? I mean, aren't you taking 4 different stats classes or something last time I looked? Right? The calculus-based stats, and then linear regression, something like that, or applied. Interesting stuff. Anyway, so stats is awesome. You guys will love it, I'm sure. But you've taken a lot of math classes. You should know how order of operation works. and you shouldn't be confused by stupid things like this. Please. Okay? Cool. You guys are smart. You guys are batting 100 there in chat. All right. Oh yeah, this, did I tell you about the peanut butter and jelly example? Again, it's much more fun to do in person because it's so messy. But if I ask you for how to make a peanut butter and jelly sandwich, right? Most of you would like write it down. I said, write it down step by step by step, and I'll follow your directions. And a lot of people, because they hadn't seen it before, they'll say, take the bread and put peanut butter on it. So I'll grab the peanut butter jar and I'll put it on top of the piece of bread. I won't open it. I won't use a knife to spread it. I'll just put it right on top. And this is my example of how dumb computers are, right? If you don't tell it to open the jar and you don't tell it to take the knife and scoop, it's not going to do that. So we can't skip any of those steps. And it makes for a fun example. There's silly videos online you guys can watch, which are maybe more interesting than me holding up a peanut butter jar and my webcam. Sorry, this remote thing is a little bit awkward still. I do like having people there in person, but we'll be okay. So our technical term for that series of steps, when we break a problem down, is an algorithm, right? You will write lots of algorithms to solve problems. And ideally, that's what we're doing with our program. We're solving some sort of problem. Again, the problem, quote, problem, and it feels weird to do air quotes, just by myself in a room here. The problem we're solving with the hello world example is saying, hey, we need the computer to say hello world on the screen. It doesn't feel like a real problem that we're actually solving or anything interesting, but that's the goal, right? We have a task we want to accomplish. That's the thing we're trying to solve. We're going to break it down step by step by step by step, right? So we need to develop that algorithm, figure out the computation of what it's going to take to do it. And that's all it is. And that is actually the hard part of coding. Again, I know you're new, and that's okay. And it feels like the hard part is figuring out how to make Python do things. But I promise you that feeling will go away, and you'll be stuck with that feeling of, oh, how do I take a big problem and break it down into step by step by step by step by step, little tiny pieces to make the computer do things, right? Because that's the big part of it here. Hang on, I gotta grab my little back support. This thing is awesome. All right, there. Now I can actually sit up a little bit more proper and not be quite so slouchy. Turns out sitting at a desk for 10 plus hours a day, if you like hunch over your computer like I tend to do, it can irritate your back. So do be careful with your health. Someone was asking in Discord how you get the GitHub repository link. You need to email me your GitHub username. GitHub username. And again, I'll create those repositories after I'm done here. So email them to me. I'll make you repositories. You can click the link that you're going to get emailed to invite you to collaborate in the repository, and then you'll be able to commit changes to your personal repository for the course. Again, they are private, so you can see them and I can see them, and your unscrupulous classmates will not be able to copy your homework off of you just because it's online in the cloud on someone else's computer. It's private, at least hidden behind your username and password. And you can even do two-factor authentication with GitHub, which is fantastic. So, excuse me. Strongly recommend you guys take advantage of two-factor authentication anywhere you can. And just as a fun little tidbit here, I know hopefully you'll learn more about security later. There's this website, Have I Been Pwned? I forget what it actually is. I think it's all just one word here. Yeah, haveibeenpwned.com. There's a security researcher who runs this. I think it's Troy Hunt. Yep, Troy Hunt runs this one, and he has collected stuff from the dark web, or wherever places he can find things, collects all the account information that's published online places, and you can put in your email address and see if that account has been hacked. You can also search for passwords and see if your password has been compromised. Right? So if you use like little dog or something and see if it's been pwned. Oh no, that's been seen in 2,788 different sources here. So it's pretty cool. And the way this works is actually super interesting. You can learn about this in other computer classes, but it does this cool, it's like a rainbow table, I want to say, or I I forget the term. One of the smart guys at my shop showed us how this sort of thing works, and we actually implement a similar process to check passwords on our systems. So super cool. This guy does it. Check it out. But again, two-factor authentication will hopefully save you. Again, it's not 100% secure. There's some silly things people can do to get text messages sent to your phone, also sent to their phone. So if you can use an app, you're even better. So the SMS, the text message, two-factor authentication is still a step better than nothing, but someone who's super determined, not that you guys probably have access to anything worth a whole lot of while, so they probably won't bother. Typically they target big organizations or companies that have lots of data. You can set that up and get a little bit more secure access. The Duo application, I think all of you guys are forced to use now, like to get into Canvas and other things, the web registration site. You can add other accounts to Duo to do its two-factor authentication method. You're not going to get the push notifications, but you can go in and it will generate that code for you all the time. That's cryptographically secure and all that good stuff. And sure, so that's a good practice, good habit. All right, where were we? Oh, the Python interpreter. So what we're using here is a development environment. Remember, I think I showed you on Tuesday, if you just run the Python executable, you get that little 3 greater than signs. That's right, it was math professor confirmed. 3 greater than signs as a prompt. We also, when you install Python, get this thing called idle. I'm forgetting off the top of my head what idle stands for, but it is a REPL environment where you can write code and it will store those variables for you to use later on in its run. So you can set a value here. We can say like number equals 10. And then I can use number later on, and then it's going to give me 10. Or I can say print number, and again, it does. So it is assuming you want to print things if you just type their number in. Is that big enough? I should make this larger. Configure idle. Font. I can do Comic Sans. That is amazing. I'm so happy. Size 16. Okay. Done. I'm so sold on this. Super excited. What is going? How big is this? Shrink. There we go. Okay. Shrink. Again, so I can store things as variables, and I can run them here at the prompt, right? Or I can do some arithmetic. So if you're not sure what 2 divided by 2 times 7 is, you can run it and check, right? Again, we can also do that in the IDE, but this particular environment's there. I'm not particularly fond of this one. I've used it every now and then, just for like a quick, hey, let me run a few commands in Python. But again, it's not too much harder to open up Pycharm and use that. So whichever one you prefer, and then it exits with parentheses to kill it. Or you can just hit the X and it will probably close. But, so we can go to there. So that's the Python interpreter, right? It will interpret Python commands as you give it to them, or as you give it to Python, rather than telling Python to read your script file. Right? Like when I run this, it's actually saying, hey, Python executable that's right here, the one from my virtual environment, run this file. And we get that console output. Again, we get that in the IDE because it's awesome. So that's it. So we can do cool things, right? You can say, like their little example here, we'll jump right into it. Well, no, we'll skip theirs. You can see their example later. Let's do a temperature conversion. So we're going to say temp in Fahrenheit is what? How hot is it out today? So it's like 80 degrees, right? Or so, maybe in Fahrenheit. And what we want to do is we want to get a temp in Celsius. Now, what we have here on the left, these are called variable names. So I'm telling Python, hey, I want to save something by name. So here's the name for it. Anytime I use temp in F anywhere else in my code, I want you to get the value that I've assigned to it. So the equal sign here does not actually mean equals. It's called the assignment operator. We're assigning the value on the right to the variable on the left. And we're going to do this all throughout Python. So we set values using the assignment operator. And then I can go get the values later. So I can say, hey, the temp in Celsius, we're going to assign the value of. So in terms of how this executes, the thing on the right is evaluated, and then it's stored in the thing on the left. So if you guys remember your math class, right? This is a common math class exercise. We take our temperature, so our temp in Fahrenheit. I don't want to take the 80, right? Because I want to take it by name here. I have a name for it. It's my variable name. No, that's the R syntax using the dash arrow stuff. We don't do that in Python. At least as much as I know. I've never seen it before. So temp and F, and we need to subtract 32 from it, right? And then we want to multiply by 5/9, right? I think that's the correct formula. Now, if I just run this, am I going to get the right temperature back out? Why don't you guys take a guess, yes or no? I'll drink some coffee, because I know Twitch is a little bit behind. That's okay. You guys don't have to guess. Let's run it. Uh-oh. I didn't get any results. I never told it to print. Oops, I should say print temp in C. When it comes to variable names, the Python preferred syntax, or unless you're someone else changed it, I think Google might even have different standards because they're weird, but most people I know who do Python, you put underscores in between words. Another common way of naming variables, and you'll probably see me do this because I'm also teaching C++ and Java, is what we'll call camel casing, where every next word gets a capital letter. I don't care which one you do. Use whichever one you want. No big deal, right? Whatever works for you is fine. Sure. When you get a job, follow the format that the people who write your check tell you to, and life is probably good. Right? It's not a battle worth fighting because it doesn't matter. The variable names here are for people. Python doesn't care, right? And I'm actually quite a fan of long variable names. If I could spell Fahrenheit without mistyping it, I would probably write that out. And if I could spell Celsius without mistyping it, I'd probably write that out too. But again, I don't want to try my luck here and misspell things. So yeah, I'm just going to abbreviate that one, and that one's probably relatively well named. But the idea is that your variable names should give you the context of what they're storing. And you should be able to know, based on its name, what it is that it's referencing, or why it's storing this value, what it's for. Right? So now if I print the temperature in Celsius, are we going to get the right number? 62 degrees Celsius. No, that is awfully hot. Do you guys remember what happened? 32 times 5 divided by 9, subtracted from this. Oops. That's no good, right? Order of operations. Use some stinking parentheses. And it shouldn't matter here, right, if I remember my math. Anybody who knows math better than I am can check me on it. But, oh, I never finished telling you my story with getting my degree in information technology. Oh no, I had to take stats, so I never took calculus. That's where I was going with that, after I fell in love with stats. I never took calculus. And recently, when I was coming back to work on my doctorate, as a prerequisite, they wanted me to have some credits of calculus. So I went back just 2 years ago, maybe? 2, 3, 2? Not all that long ago, within the last 3 years, and I took Calc 1 and Calc 2. And I had to take Calc 2 twice. Turns out I'm not as good at remembering formulas as I used to be when I was much younger. And not having a cheat sheet with the formulas on it caused me to get a 68-point-something% score, which was a D+, which was not enough to transfer credit. C's get degrees, right? Not D's. So I had to take it a second time, and I did much better the second time. I think I might have even gotten a B on it. But it was super interesting. Calculus is, you can do some cool stuff with it, but again, possibly not as practical depending on what you're working on. I think stats is much more applicable. But anyway, let's try this again now. We'll see if this works. So 26.6. So that's probably much closer. Let's consult the almighty internet. So 80 degrees F to Celsius, F to C. It probably knows what I want. Bing and Google are pretty smart. Look at that. We have the right formula. Amazing. We have done it, folks. Well, that's all it is. So this is my algorithm, right, to take a temperature from Fahrenheit, right, and turn it into Celsius. That's all it is. Now, again, you're probably remembering when I said most programs need some sort of input. Otherwise, they're really, really, really boring, right? Well, yeah, that's true. It is really boring when you do that here. So what we want is we want a way to get some input. So what we can do in Python is we'll say the temp in F is equal to, that's right, I don't even need all these new lines, equal to input. It's asking someone to input. And I can even give them, inside of here, a prompt. And I can say, please enter a temperature, that's probably right, in Fahrenheit. Again, just F, and that's probably fine. Whatever gets typed in here is going to get saved in this value. It's just fantastic. Now I'm going to put, this is called a breakpoint. You're going to learn to love this debugger here. So when you run your program in debug mode, if there's a big fat red dot there, a big breakpoint, it's going to pause. And it will wait to do that next statement until you tell it to, which is awesome. So you can actually see what's happening, because we're going to run into some problem here. So don't hit run, hit debug if you want the debugger to work. That's definitely an important step. All right, so enter a temperature in Fahrenheit. Let's try 80 again. And now I hit enter and I get to the big fat red dot and it pauses. Now inside of here, you've got this little variables window. Can I not make that bigger? There's a way to make this bigger. I don't know what it is at the moment. I'm sorry. I can Google it later. Or maybe just, I'll try it later. But if you can see, it says, here's the variable, temp in F, and then it has str quote 80 quote, or single quote, or apostrophe, whatever you want to call those things. So what this str means is that I now have a string. Remember when I typed in hello world? This is what we'll call a string. A string is nothing more than a bunch of characters, or one or more characters is a string. Technically one character can be a character, but one or more we'll call a string. That's probably fine for our purposes. So if I have a string value here, it turns out you can't do arithmetic on strings. So let me hit stop. I'll just run it and you can watch it crash on me, because that's more fun, I guess. Maybe we should have done that first. It crashes. Ooh, this is what we call a stack trace. Again, the stack won't mean a whole lot of things till we get till chapter 7, maybe? 6, 7, somewhere in there. But it tells us, hey, in your file at line 4, you had, this was the line, you had a type error. Unsupported operand types for str and int. For string and int. No, we don't use a semicolon. So lines are just separated by white space. Python uses white space for all sorts of things, which is a little awkward to get used to if you've programmed in other languages. If you've never done it before, you'll get used to it, and then you'll think the other languages are silly. So turns out you can't take a string and subtract from it. You can't do that operation. It's not the correct type. So in Python, it is a typeless language. If you've done any other programming in other languages, usually you see when you create a variable, you're telling the language what type of variable it is. Like you would say, hey, this is an integer value because it's going to store whole numbers. Or this is a string value, it's going to store text. Or this is a double value, it's going to store floating point numbers or numbers with a decimal, essentially. Python is typeless. It infers the type from whatever you're assigning to it. So if I'm assigning what I get back from input, input will only ever give me strings. And this is a little bit obnoxious because now we have to figure out how we take a string and turn it into an integer. But it turns out it's not actually that hard. We say int in parentheses. So again, we have order of operations. The parentheses happen first. So I get this prompt, whatever I type gets saved here, gets returned as input. We then hand it to the int conversion. It will try and turn a string into an integer. And then we should see if we can get a temperature back out. Let's try that. Again, if you like it all in one line, fantastic. You can do it separately. Oops, 8 degrees. Oh, negative, right? 8 is below freezing, below the freezing point in Fahrenheit. So that's probably correct. It worked out okay for us. You can, if you want, have something like the string input is this. Some people prefer this when they're getting started because it's broken down step by step by step by step, a little bit easier for some people to follow. So go for it if that's what you like. But it does the exact same thing, just putting it inside instead. And it's ever so slightly less efficient to do it this way because it has to save this in memory. Remember we talked a little bit about computers. Did we talk about computers and hardware and software and how they process things really fast? I'm sorry, all my things are blurring together, all the different classes. So I have 3 different intro classes. So slightly less efficient. For our purposes, we don't care. That's fine. Not a big deal for us. All right. And then basic input and output. Yep, we're doing that. Fantastic. I'm just making sure I'm essentially following along with our textbook here, but not too big of a deal. That'll do. That'll do. Yeah, more conversions. Great. They have all that. And you will do lots of practice, I promise. It is good to practice. Errors are good. Other things you might run into are syntax errors. So if you are missing something like a parenthesis, it's not even going to try and run here. It's just going to fail on us because it doesn't work. So we need to follow that syntax. That's the rules of what Python expects before it's going to compile. So definitely some programming good practices or best practices is write some code and try it. Write some code and try it. Right? Go through that process of I've got the idea, I've got the task I want to solve. Let's break it down into some steps, figure out what I need to do to tackle it. I usually say if you can't solve the problem in English, like if you can't describe how you're going to do it and what the steps are, you're not going to have any luck in Python or Java or C++ or any language, right? Because if you can't understand how to solve it, you won't be able to do that translation of the steps into the computer syntax, whatever your language is here. So break things down into small steps, write them and try them. You're best off running often. This is super easy to run code. You don't have to worry about any of that. Right? It is fast. So it's not like it's hard to be running this over and over. So try, add a couple lines of code and try it. Add a couple lines and try it. Add a couple lines and try it. Don't write 100 lines of code for your first project before you ever hit the run button. Because when something doesn't work, you're going to be kind of frustrated and not really know exactly where your error is. So just be careful. All right, so we can do our conversion here. If it does crash, right, I don't know about you, but there seems to be nothing quicker that can just put me in a bad mood than one of my programs crashing, whether or not it's on my computer or especially on my phone. Like if I'm using my phone and one of the apps just locks up and freezes and crashes, I get irrationally upset for some reason. I'm just like frustrated, like, oh, this stupid thing. And you don't want to do that to your users. You want to make sure you don't crash. So, and there's things we can do later on. We'll talk about how we can keep our programs from crashing, best practices. But for now, if it crashes, try not to get too upset. It's life. It'll happen when we're learning. Take that as a chance to figure out what happened. Look at that little stack trace, see what line went wrong, and you can go from there. So a couple common errors you might run into: syntax errors, right? If it's a syntax error, you just did something wrong and Python can't understand it. You can have indentation errors because Python uses white space for things. If this was tabbed in here, it's upset and it says, hey, there's an indentation error. Essentially, everything has to be left aligned. You can't space different commands. We'll change that rule once we get into more complex code, but for now, everything stays left aligned. Spaces have a lot of meaning to Python. You might have value errors. So if I try and run this and it asks for a temperature and I say 80, E-I-G-H-T-Y, I get a value error, right? Invalid literal for int with base 10, 80. You kind of read these backwards a little bit. So we gave 80 to the int conversion, and it said it's not a base 10 number. It's not, the literal value is not a base 10 number. So that's a value error. We just did the wrong thing. We might also have name errors. So we can print like temp in C. Python is case sensitive. So if I say temp in with capital here and I go to run it, I'm going to get the name error. 80 degrees. Name error. Temp in C is not defined. Not defined means I haven't declared it and given it a value. So I could say temp in C up here, but I need to give it some sort of value. So I'm assigning it, I don't know, 0. If I do that, I can use it later on. So again, your code is, the order in which you call it matters. So you need to declare your variables before you use them. hopefully that makes sense, right? We're very top down. So this, using a variable haven't declared and given value will give an error. And that's pretty close to fitting on one line. Again, it should be okay in your screen. There. The typical rule of thumb is you don't want to have to scroll left and right to see your code. And this can be a little bit tricky in Python because we don't have like a semicolon that says end this statement. So it's harder to do things on multiple lines, but not impossible. So we'll get there later. We'll tackle that. Not too big of a deal. So those are errors we might run into. And then in terms of stuff that can go wrong when we're coding, right? We call them bugs because someone found an actual bug one time in their code when it used to be printed on these little note cards and you had to take it over to the mainframe and do all this nasty stuff. And that just sounds terrible. Some people like get all nostalgic when they talk about those card machines and whatnot, but sure. People were better back then because it took like half an hour or something stupid for it to process. So you made really sure you didn't have a syntax error or a name error or anything before you turned in your stuff, because it would take you half an hour for it to fail. You'd have to go fix it and wait another half hour to see if it actually fixed. Right? We're probably a little bit lazier and spoiled now, because like with just a push of a button, I can change and try again. And sadly, in terms of quality software that gets distributed widely around the world, I don't know how often you've seen your apps update, and it's just like, oh, bug fixes. Like they just don't test it well enough because it's so easy to fix. And not that they don't test it. I mean, and it is hard to write code that doesn't have bugs. I will fully admit that. And I'm not saying that they're terrible people because they have bugs, but maybe we could spend a little bit more time on some quality assurance testing and not have to release so many patches. But okay, it's kind of a side effect. So you might have bugs. So there's really two kinds of bugs. The first kind of bug is we just typoed something and an error happened. Right? We just did the wrong thing, and that's a bug. We can fix it. Notice this thing that I showed you was called the debugger, right? Where we step through, we can debug our code. As we step through it line by line by line, we see the values. It helps you find those bugs in your code because you're like, oh, that shouldn't be an 80 as a string. That should have been an integer value or whatever it happens to be, right? Or your calculation was wrong. You can see the individual values, and this will make a whole lot more sense when we do bigger projects. Chapter 1's kind of boring in terms of we just don't cover a lot. But we will debug it. The other problem you might have is a logic error. And debuggers are also good for finding your logic errors, where if I said, like if we were to multiply by 9/5 instead, right? If we forgot our formula, that's a logic error. The program will do the right thing, and it's not necessarily a bug in that it's going to crash on me, but it's a bug in my logic. So I have told it to do the wrong thing. So logic bugs are difficult to find. The best way to find them is to run your program. Say, okay, I know what my algorithm is supposed to do. Right? I give it this value, it does some calculations, it spits out this value. You should be able to tell, given an input value, what the output value should be. So run your program and try it. Hey, let me give it 100 degrees or 212 degrees Fahrenheit. Does that give me 100 degrees Celsius? Perfect. All right, looking good so far. Let's run it again. If I give it 32 degrees Fahrenheit, do I get 0 degrees Celsius? Yes, I know the boiling and freezing points of water. That's a pretty decent test to see if I'm going to have any logic errors with my code here. So do that. Right? Find the bugs, fix it. Oh yeah, they even have a picture of the bug. That's cool. Zybooks is handy. The white space matters in Python. Right, that's okay. You can read all about that. This equal sign does not mean equals. This is a really common mistake early on. It means assignment. We're assigning something. So if you want to compare if something is equal, you use the double equal sign. And we're not doing that right now, so don't worry about it. We'll get to that in a little while. And then the rest of the chapter is just practicing printing stuff and inputting things. It works out pretty nice and quick. So we're kind of easing into it here. They recommend particular IDEs. Sure. And some websites, that's fine. Oh, and there's the little information about computers. Yes, the Xylabs count towards that 10% of your grade that you're going to get for Zybooks. Dr. Beast. So try not to get behind on them because they are sort of time consuming, but I'm quite fond of them because it forces you to pay a ridiculous amount of attention to, do I have a space here or not a space here, and those sorts of things. That it's just a good way of practicing that level of detail. When I check your code, I'm going to be honest, when you turn projects in, I don't even run them half the time. I've done this long enough and often enough that you can give me a link. Let me come and commit this here. So we're going to say, here's some examples with input for F2C. Again, your commit message should be meaningful. If you want to be funny and clever, go for it. If you want to put swear words in there, I'm not going to care. You're not going to offend me at all. But get into the habit of making these things meaningful and useful. You'll just be better served rather than trying to have to unlearn a bad habit. So once I commit and push, what I'm going to do, because you give me links to your github.com repositories with your code, come on, refresh, enhance. There we go. Most of the time when I'm grading your projects, I just will read the code here and I can tell if it's going to work or not. It's not 100% the case. I've gotten projects that just make me scratch my head and then I'll go and run it. Right? It's easy enough for me to go do. I can either clone your repository or I can just copy it all into my Pycharm here, because Python is amazing, and hit run, and I'll see if it gives me the right results. But I can usually just eyeball it and tell whether or not it's going to work. So when I do that, though, I'm not checking for, do you have a space here between the $sign and the decimal, or do you have this sort of thing? And I don't get to that level of inspection, and that's what I appreciate that Xylabs does. Again, it's training you for different things, right? I swore a long time ago when I was an undergrad and I took a project, or took my intro to coding class, that if your program worked, you would get points, because I'd gotten marked down for not having a comment. And I think I mentioned comments. This $sign, this is not a hashtag, this is a $sign, right? Pound sign. If you call it a hashtag, I'm going to make fun of you, just because I'm an old grumpy man now. This is a comment, and anything after the $sign Python ignores. So what people do is they leave comments, right, and they say whatever they want to say about something here. So it's really a note for you or for whoever's going to be reading your code. Some people love comments and they say you should comment everything. And I missed a comment, or I didn't put it in, or I forgot, whatever it happened to be, and I lost a point on my assignment because I didn't have the comment, but my code did exactly everything it was supposed to do. It was perfect. And I lost the point. So I swore to myself that if I ever got a chance to teach, I would not take points off as long as the code works. And I've stuck to that. So I've gotten some really ugly, nasty looking code before, but it works, so they get the points. Right? There's other classes you can take. It will take more practice to learn to have prettier code. There's books you can read about it. Again, I want to know if you can solve problems and if you can use the tools in the language to solve those problems. That's what I care about, and that's how I'm going to evaluate you. So I don't ask for any comments ever, because I don't. There are really good reasons to leave comments, and there's some really cool stuff you can do with comments for some sort of documentation, which is fantastic. Again, I feel like that sort of thing you can just Google and do it if someone asks you to do it. It's not too tricky. So that's that one there. All right, let's see. Computers, programming. Oh, good. They do show you a little bit of hardware and software. You can go read about that. A couple of the things real quick that we care about. We have memory, which is RAM, the random access memory. Don't call it RAM memory, because you're saying random access memory, and just don't do that. But RAM is the temporary short-term storage. That's like the short-term memory brain of the computer. It's really fast to put things in and take things out of RAM. So when we say, hey, tempnf equals something, what's happening behind the scenes is Python talks to your operating system and says, hey, I need a place to store an integer value. And your operating system says, oh, okay, here's a location in memory. And for some reason, we address these things using the hexadecimal system. Again, you can learn more about that in other classes. It's base 16. So it might be something like x53f is your location where we're going to store this thing. And what happens behind the scenes is anytime we use tempnf, what Python is going to do is say, oh, tempnf is whatever value is here at x53f. It's going to go ask for it from memory, plug it in here. Just like using variables in math class, right? It's saving it, but where it saves it is RAM. And RAM is generally pretty quick. which is nice. What is not quick, in comparison at least, is long-term storage or like disk storage, saving something on your C drive, a flash drive, a network drive, whatever it happens to be, a DVD, a CD, those sort of things. That's typically slower than RAM. Takes a little bit more time to get it. And we'll get into those input, output operations, file I/O stuff. We'll be doing some practice with that later, so we'll have a chance to play with that. But that's typically slower. But the good thing about disk storage is that when you turn your computer off and there's no power, it stays there because we've used magnets or whatever to store that information. Or in a solid state drive, we've flipped the bit somehow and it stays. With RAM, when the power gets cut, it loses all of its information because it's not keeping electricity there. We're gonna lose it. You're gonna lose the information in it. Functions we get to in chapter 6. There we go, chapter 6. Yep, functions in chapter 6. So we get through the whole Zybook, which is fantastic. Although I do think, what is it? The last chapter I think I marked as optional. Okay, so there's a standard library, a reference thing, searching and sorting algorithms, and then some additional stuff Zybook's put out there. The chapter 18 additional material programming in Zybook's like tells you about the window there. So you can read about that if you have any troubles or questions with it. Again, I'm happy to help. Shoot me an email, find me on Discord, we can do a screen share session or something. I'll typically have office hours after lecture is done. Hopefully that works out best for you. If that doesn't, shoot me an email, text me, call me, find me on Discord, and we can do something by appointment too. That'll work out okay. So, all right. Awesome. I think that was it. Let me just double check here. We got all the stuff. Again, a warning. Just because I didn't say something in lecture doesn't mean it won't be on the quiz, right? Typically what I try and do is have the quiz come out of the textbook. Again, I'm picking out those important things that I think are the most important for you to find and to hear, so that you're going to get the gist of it in my time with you. So that'll get you a lot of the way, but do expect questions to come out of the textbook that I have not ever mentioned before. So if it's in there, again, you don't need to memorize every single word, but know where this concept is talked about. And do the reading. You definitely need to know more than just look at the topics. That's not going to do very well for you, but you can go look it up when you take the quiz. I'll be posting that later today. It'll be due, might as well just have them do like Fridays, 11:59 p.m. or something. And that'll be okay. So do the quiz. The first project we won't start until after we've had time in lab, where I can make sure everyone is up and running, got set with GitHub, we've done all that stuff. So we'll probably start our first project this week, and then we'll do a project about every 2 weeks. We'll have the first project, we'll have a second project, we'll have a third project, and then a fourth project, and then we'll do our final project, I think is the goal. 1, 2, 3, 4. Yeah, so probably 4 projects, again, to make up this 25% of your score. Then your final project is worth just as much as the rest of those combined. I do usually like to have people do this in pairs when we meet in person, but because we're not meeting in person, that's a little bit tougher to do, and I don't want to force you guys to do all that sort of collaboration work. So it will be an option for you. If you know someone else in the class and you get friendly with them, you can pair up. Great, go for it in the final project, but if you want to do it by yourself, that's perfectly fine too. So, hey, thanks, Colehawks, glad you could drop in. That's kind of part of the fun of doing this thing on Twitch here. It's open for anybody, and I got the inspiration from the Knowledge Fellowship. If anyone in Twitch chat wants to drop an !TKF, the Knowledge Fellowship, we got some links for some other interesting streamers who just want to share their knowledge. Once you email me your github.com username, I'll be making a repository for you. I'll be doing that after class, sitting around, and then I'll post the link to our course one here. So all of the code that I write, you can find the examples for on github.com. I don't think anything else changed. Life is good. Let me go to announcements, and I'll throw that one in here. So I think that's all I got for today. Do you guys want to go raid someone else's channel, and then I'll hang out in Discord and we can do some office hours, answer some other questions. Yeah, let's see who else is on right now. Hey, we can go check out Prof. Melko here. So I'll take you over there. It's been fun. I'll see you guys on Tuesday. Enjoy the holiday. So let's see. I think he turned his raids back on, so I'll see you there. Oh, there's a 10-second countdown. Okay. we're getting there. All right, totally optional. Again, this is just part of the fun of doing this here. So if you want to, have at it. I'll see you guys later. Hey.